Okay, so we are in your journal of multi-step inequalities. You know how to solve multi-step inequalities. So basically this lesson is just about how to use interval notation. So interval notation, it's another way of expressing the answer to an inequality. It uses parentheses and brackets to show where the graph starts and ends. So this is not special to me in particular. This is just interval notation used in Algebra 2 and Pre-Cal and Calculus. So we are learning how to write the form in another way. And we start easy by doing multi-step inequalities. What I want you to understand first is that if I asked you x is greater than 5, what does that really mean? It means that we're working with numbers that are greater than 5. But could x be 5 to this solution? No, it can only be numbers greater than 5. So this is expressed as an inequality, which you're familiar with. When you express this on a graph, which is what we did before in Unit 1, we said it was open circle and then we shaded to the right. And we shaded to the right because it matched this arrow only because our variable's on the left-hand side. That's very, very special. So for this homework and for this journal entry, what we are focusing on is not only the inequality, right here, not only the graphing, but now we have something called interval notation. So when you look to see what we use, whether it's brackets or parentheses, I want you to understand parentheses means not included. Just like if x were greater than 5, 5 is not a solution. So we use an open circle. And we use an open circle if it's like greater than or less than. Brackets are kind of like x is greater than or equal to 5. It means 5 is included. So whenever you see more ink right here, you have more ink on your inequality. So closed circle represents that that number can be a solution. So what does that look like? Well, and then we always use, one more thing on the notes to fill this in before we get to an example, is that we always use parentheses with infinity or negative infinity. And why is that? Because I can say that x is equal to 5. Like for sure x is equal to 5 or x is equal to 3. But I can't say that x is equal to infinity. So it's never a bracket, it's never a closed circle because we don't know what negative infinity is and we don't know what positive infinity is because you can always plus 1 or subtract 1. So parentheses is the standard when we include negative infinity or infinity. So let's take a look at what that means on number 1. We solve this like we would any inequality. We distribute the 4, so I get 4x plus 12 is greater than negative 24. I subtract 12 on both sides. I get 4x is greater than negative 36. I divide by 4, and x is greater than negative 9. So, is negative 9, a solution? No, it's not. Here are a couple things we need to know like we did last unit. Your target number, which is negative 9, starts in the middle, and then you have integers to the left and integers to the right. So that's how we fill in our graph. I know it's going to be open circle, and I know I shade to the right. So here's my inequality. Here's my graph. That's what you've done. What is different is interval notation. When you look at interval notation, we read our graph from left to right. So if I look over to the left, nothing's here, nothing's here, nothing's here. Here's where my graph starts, at negative 9. It is open circle, so I have parentheses on negative 9, and then I look to see where does it end on the right. How far is this going to go? It's going to go to infinity. So I go to infinity. So on interval notation, you have the left-hand side of the graph and the right-hand side of the graph. So go from left to right. So this tells the reader that negative 9 is a part of the solution, that numbers greater than negative 9 are a part of the solution, and it's going to go all the way to infinity. All right, let's look at number 3. Okay, I distribute 7x, negative 2x, positive 8 is less than or equal to negative 2. So I distribute, I combine like terms, and I get 5x plus 8 is less than or equal to negative 2. I subtract 8 on both sides, and I have 5x is less than or equal to negative 10. And I divide by 5, which is a positive number, so I don't flip my sign. and I have x is less than or equal to -2. So when we fill in my graph, my target number is -2. I go integers to the left, integers to the right. It is a closed circle on -2, and I'm going to shade left. So if I look to the left over, where does this graph begin? My graph begins way, 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 way down there at -infinity. So infinities, whether negative or positive, has a parentheses because it's open circle. I don't know what -infinity is. Comma, where does it end? It ends at -2, therefore it's blocked off at -2. It's not a parenthesis, it's not open circle, it's a block on -2. Okay? So, let's do number 6. Number 6, so I'm still going to solve -5x on both sides. I get -3x minus 1 is less than or equal to 20. Add 1 on both sides, and I get -3x is less than or equal to 21. Now I'm going to divide by -3. Remember, when I divide both sides by a negative, what needs to happen? I have to flip my sign. So it becomes x is greater than or equal to -7. So when I look over here, my target number is -7. I have -8, -9, -10, -6, -5, and -4. It's going to be a closed circle because x is greater, it's greater than and equal to -7. So it's closed circle, shade to the right. Now, I read this graph left to right. Nothing's going on down here at -infinity. It's going to start at -7. And because -7 is a part of this solution, I have a bracket right here. Comma, where does it go till? It goes till forever in the positive infinity direction. Okay? So that's what an interval notation looks like, and that's what it means. If you have questions, come and see me. Come and see me in tutoring. Otherwise, good luck on your homework.